Here, we're going to walk through executing some statistical tests in Excel. And some of them will just be living calculations like you will normally do in Excel, but some of them will be using the data analysis pack in Excel. So we have some student data here, some student measurements, and you can see that 3 of them look very close to each other, where the 4th looks like an outlier. So we're going to execute a Grubbs test using this equation to determine G experimental or G calculated, and then we're going to compare that to the critical value of G to see if we can get rid of this. Okay, so I think this is an outlier. Okay, so I'm going to calculate G. In order to do my G calc, I need the average value and the standard deviation of the values. Okay, so I've got average and standard deviation I need to calculate. Okay, I'm going to execute those functions like we did earlier. Okay, there we go. And now I'm going to make sure I have the proper number of decimal places everywhere. Okay, and then I'm going to execute GCalc. Now remember this X question mark, that's the questionable value, so that's the outlier that I think I've got. So G calc or G experimental, right, is going to equal the absolute value. So here's a new function. ABS is the absolute value of whatever's inside the parentheses. So I've got my questionable minus my average. Okay, and then that whole thing divided by my standard deviation. So my GCalc here is 1.473-ish. Okay, and I'm going to go to my critical values of G at 95% confidence. I'm going to say, okay, I've got 4 measurements, and therefore I'm comparing this to 1.463. Okay, so my calculated value is greater than 1.463, which is my G table value, and therefore because my calculated or my experimental value is greater than the table value, I can discard that data point. So here I can discard this. Okay, and now I'm going to calculate a new average and standard deviation. You can just change this calc here, but I think it's important to keep track of what you've done and what you haven't done. As soon as you change this calculation, it'll change this calculation as well, because we're using living spreadsheets. And so I'm just going to redo it here so that my Excel spreadsheet is as complete as possible. Okay, and I'm only using the 3 values that are left. So these are the ones I'm going to be using now for any other calculations that I need to do. The next thing on the list is a percent difference. So here I have a true value, okay, and I have my measured value, average standard deviation. So I'm going to do a percent difference between the two. So here I'm going to do a percent difference. And the equation for that is down here. We have the true value minus the experimental value, and that's an absolute value of those, divided by the true value times 100%. So absolute value of true minus my experimental number divided by true, and then times 100%. Now I will point out that order of operations here, division and multiplication, will always work out the same. If you're worried about order of operations, you can put this whole quantity in parentheses, but it should be the same because of order of operations, the same way you do math on paper. So times 100%, so my percent difference is 0.0145. So that's good. Let's just see if it's just times 100. There we go. 1.45%. Okay. So that's pretty small, and you'd say, okay, I got some pretty good numbers here, but your measurements here are pretty tight, and they're all a little higher than the true value. So let's execute our confidence interval and see if statistically, to what confidence can we say that this true value lies within our distribution. So we're going to execute the confidence interval. Okay, and the equation is down here. It's the average plus this quantity, and then the average minus this quantity. That's going to give us 95% of our data points would fall in that range. So I've got the average value plus, all right, a t value. We're going to use the 95% confidence interval value, and that's going to be dependent on the degrees of freedom. So if we have 3 measurements, the degrees of freedom are 2, so we have a 4.3 here that we're going to plug in here. So 4.3 is my t value in this case, and actually I'm going to put that in a different cell just so that I have I can refer to it. So I have 4.30. Okay, so this is my average plus t times s divided by the square root of n. So I'm going to use that square root function, and the number of measurements that I'm including here is 3. Okay, so I closed my parentheses on the square root. I'm going to close my parentheses on that whole term and enter that. Okay, so that's the highest that my range could go. If I copy this down, I want to make sure I'm referencing everything correctly. So I've got t, I've got the average and the standard deviation, and I'm just going to change this to a minus. Okay, 1.748. So it looks like the true value does fall in my confidence interval, and so that's really good news. So our percent difference is 1.46% difference. That seems really small, and we are just barely, the true value is just barely within our distribution.